Ultrafaint dwarf galaxies could reveal secrets of the early universe.
Small galaxies orbiting the Milky Way, almost invisible to our telescopes, may hold valuable clues about the earliest moments of the universe.
Called ultrafaint dwarf galaxies, they are the smallest known and function as cosmic fossils, allowing scientists to better understand how the cosmos formed shortly after the Big Bang. A new study carried out by researchers at the Oskar Klein Center in Sweden, in collaboration with universities in Durham and Hawaii, has brought important advances in this area. Using extremely detailed computer simulations, the team showed that these tiny galaxies are sensitive to conditions in the young universe, helping to explain why some were able to form stars and others remained as dark clouds of dull matter. Ultra-faint dwarf galaxies are up to 1 million times less massive than the Milky Way. They form inside small halos of dark matter, structures predicted by cosmological models. Because they are so fragile and small, they have always been difficult to study and simulate accurately. Now, with a new set of very high-resolution simulations, the largest ever created for this type of object, scientists have been able to follow their development over billions of years. Azad Fatahi, associate professor who led the work, explains that the simulations reveal how the initial conditions of the universe influenced the fate of these galaxies. Sean Brown, another lead researcher, uses a simple comparison: just as harvesting a crop in the summer reveals what the weather was like in the spring. The current characteristics of these faint galaxies tell a lot about the weather of the universe when it was less than 500 million years old.
The results show something fascinating. Smaller galaxies are extremely sensitive to changes in initial conditions, such as the radiation present in the early cosmos. Depending on these conditions, a small halo of dark matter can form stars and become a visible galaxy or remain dead without any stars. Larger galaxies, like our Milky Way, are almost unaffected by these variations. This discovery is especially exciting because it opens a new window to study the infant universe, future. Observations from the Vera C. Rubin Observatory should discover nearly all of the Milky Way's satellite galaxies, including many ultrafaint dwarfs. According to the researchers, this close-in data could help narrow down what the cosmos was like in its earliest moments, something that distant telescopes like the James Webb still have difficulty fully explaining. Especially with the surprise of large, bright galaxies appearing very early, carrying out these simulations required a huge effort. It took more than 6 months of processing on supercomputers, generating around 300 terabytes of data. Old algorithms had to be updated to deal with this gigantic volume of information. Most of the work was done on the Cosma 8 supercomputer at Durham University in the United Kingdom. With these powerful tools, the team now aims to investigate other big questions, such as where the universe's first stars were found and what dwarf galaxies can reveal about the nature of dark matter. In short, what seemed like just small, faint specks in the sky could turn out to be one of the most important keys to deciphering the mysteries of cosmic beginnings. As new telescopes come into operation, these silent galaxies could tell surprising stories about how it all began.